All right. Good evening and welcome to today's class. Last week we began a new topic, and the title of this topic says trigonometry, or rather trigonometry, anyways. Under it, we discuss trigonometric ratios, and we actually make use of Pythagoras theorems as a way to actually explain those ratios. All right. Um, Today we are going to take some examples on this. Before that, I want to actually give us a particular derivation that actually goes in line with what we discussed last week. Permit me, let me just have a rough sketch. Last week we drew a triangle of this form, a right angle triangle of this form. We are told that the angle 90 is here. All right, then there's theta in this place. Here is A, angle A. Here we label here to be B, here is C. And the line facing this capital B is small b. The line facing the capital A is small a. The line facing the capital C is small c. Is that okay? Good. Now from here we're able to derive the, what's it called? The formula for all the ratios, sine, tan, and cosine. All right. Now from here, we actually said that something like sine theta, if here is the reference angle, okay, that means it's going to be opposite over hypotenuse. In short form, opposite over hypotenuse. That means it is equal to C over B, equal to C over B. Then cos theta is equal to adjacent over hypotenuse. Adjacent over hypotenuse, which is A over B. A over B. Then the tangent, which is tan theta, is equal to opposite over adjacent. Opposite over adjacent, which is equal to C over A. Okay? Now, tan theta can be equal to sine theta over cos theta. Now let's prove this. Okay? Now let's watch. Sine theta says C over B. C over B all over. Cos theta says A over B. Okay? A all over B. Alright? So what we have here is C over B over A over. That means you're going to use this to divide this. Is that okay? Using this to divide this. Okay? Now, this is more like saying, okay, I'm going to just take it gradually. C over B divided by A over B is something as saying multiply this with the inverse of this. It becomes C over B times B over A. B over A. At this point, B will cancel out B. I'm left with C over A, which is equal to C over A. And C over A is equal to tan. That's it here. Pardon me, please. This is what I just worked on. From here to here. That meant that to divide this with this is same as saying multiply this with the inverse of this. An inverse of A over B is something as saying B over A. Okay, that's what happened here. So we multiply this by inverse, which is B over A. So when B cancels out B, I'm left with C over A. And C over A is equal to tan theta here. Alright, therefore, tan theta is equal to sine theta over cos theta. Is that okay? Now let's take examples as time will permit us. Now let's say I have given that sine theta is equal to 8 over 17. Calculate, first of all, cos theta minus half. Let's calculate tan theta too. Is it? Okay. Let's calculate tan theta. Is that okay? Now let's go. At this point, we first of all employ right angle triangle. Alright? It has been our tool from the beginning. Right angle triangle. What will be his work here? We are going to know. Right angle triangle. Let me still repeat the naming. A, B, C. Well, so given that sine theta is equal to 8 over 17. Now sine theta is equal to opposite over hypotenuse, which is equal to 8 over 17. So if here is my reference angle, that means here is my opposite, then here is hypotenuse. That means here is 8, here is 17. I can call this place, let me just say small a. Is that okay? Using Pythagoras theorem, which is what is being used to solve questions on right angle triangle. So I'm going to have, listen now, his theorem says, okay, let me just put it down here first. Using Pythagoras theorem, we have that hypotenuse squared is equal to opposite squared, then plus adjacent squared. Now from here now, 17 is my hypotenuse. So I'm going to have 17 squared is equal to my opposite is 8, which is 8 squared plus a, which is my adjacent, then I square it. Okay? Here, I collect like terms. I'm going to have that 17 squared minus 8 squared is equal to a squared. Is that okay? 17 squared will give me 289. All right? I'm going to have 289 minus 8 times 8 should give me 81. 81. Hope I'm correct like this. Is equal to a squared. Okay? We continue. We have a squared is equal to 289 minus, what's it called? 81. Okay? So let's continue. Sorry, please. Here should be giving 64, please. This is 64. Not 81. 64. Okay? Alright. So I'm going to have this minus this will give me 9 minus 4 is 5. 8 minus 6 is 2. I'm going to have 225. Therefore, A is equal to the square root of 225, and that is equal to 15. My A represents my adjacent, okay? So it simply means that I'm going to have 15 here as my adjacent. Is that okay? Good. Now, here say find cos theta minus 1 over 2. Now, what becomes my cos theta? Then my cos theta now is equal to adjacent, okay, over hypotenuse, which is equal to, here is 15, hypotenuse is 17 over 17, then minus half 1 over 2. I'm going to have this times this is 30, 17 times 1 is 17, over 17 times 2 is 34. So this minus this should give me 13 over 34. So that means cos theta minus half is 13 over 34. Now let's go through this second one now. It's going to be easier now. Then tan theta is now equal to opposite over adjacent. Opposite adjacent. Opposite over adjacent, which is equal to A over 15. If you like, you can say apply this very formula. Then tan theta is equal to sine theta over cos theta. You can say apply this. Let's go and see what you're going to have. Sine theta says what? Is 8 over 17. Okay? Now times the inverse of the value of this. Value of this is 15 over 17. Okay? Sorry, the inverse should be 17 over 15. Okay? The value of this cos theta is 15 over 17. The inverse of it becomes 17 over 15. We're going to have 17 over 15. When this cancel out this, I'm left with 8 over 15. The 17 here, the 17 here. So that you use this or this, you're going to arrive at the same points. All right? Okay, that's all about today's class. See you tomorrow for more questions and more clarification. Have a good day.